The Milky Way galaxy and the Andromeda galaxy are drawing nearer together every minute, consistently, and eventually, they will merge. The Andromeda galaxy, M31, and the Milky Way galaxy, two of the largest galaxies in the local group, are on a collision course that will unfold over billions of years. While many consider cosmic impacts devastating blasts, they are actually far more smooth, like a slow-motion dance that stretches across enormous timescales. Evidence shows that this collision has already begun. As these two galaxies approach each other, their gravitational forces are starting to reshape both systems, initiating changes that will have broad consequences for the stars, gas, and other cosmic components. When you think about the universe, it's easy to imagine galaxies moving farther apart due to the expansion of space. After all, this is what the Hubble Space Telescope has shown. Galaxies retreating from one another, as distant galaxies seem to move toward the red end of the spectrum, a phenomenon called redshift. However, the Milky Way and Andromeda are part of a unique situation. These two galaxies are relatively close to each other, only about 2.7 million light-years apart, so the universe's expansion doesn't affect them in the same way. The force of their mutual gravitational attraction is far stronger than the expansion of space at such a short distance. Gravity, the key force that governs cosmic motion, pulls them toward each other at an incredible speed of 123 kilometers per second, approximately 76 miles per second. This rapid movement sets the stage for a galactic merger that will completely reshape both galaxies. While such a collision might sound like a violent calamity, the actual process is much more gradual and graceful. Since galaxies are mostly made of empty space, the stars themselves are unlikely to collide. Instead, it's the gas, dust, and dark matter that will interact, leading to spectacular new formations and cosmic phenomena. One of the first signs that the Milky Way and Andromeda have begun interacting is the discovery of hypervelocity stars. These stars are traveling at incredible speeds, up to 1,000 kilometers per second, fast enough to escape the gravitational pull of their home galaxy entirely. But how do these stars reach such high speeds? Several mechanisms can propel stars to these colossal velocities. In binary star systems and near supermassive black holes, a binary star system consists of two stars orbiting a common center of mass. If such a system gets too close to a supermassive black hole, gravitational forces can disrupt their orbits. One star may be drawn into the black hole, while the other is flung away at such high speed that it escapes the galaxy's gravitational grip. This process, known as slingshotting, can propel a star to hypervelocity speeds. When galaxies collide or pass close to one another, their gravitational forces can eject stars from their homes, especially in dense regions where stars are closely packed. Interactions between galaxies, specifically the gravitational forces at play, can disrupt the motion of stars, pushing some of them out of their home galaxies entirely. Astronomers believe that many hypervelocity stars in the Milky Way were ejected from Andromeda. Simulations and data from missions like Gaia, which maps the positions and speeds of stars in our galaxy, support the idea that Andromeda's gravitational influence is already starting to reshape the Milky Way's stellar population. As astronomers continue to search for these fast-moving stars, they uncover more evidence that the Andromeda-Milky Way interaction is well underway. In addition to hypervelocity stars, astronomers have found another clue that the galaxies are interacting: the impact of their galactic halos. A galaxy's halo is an invisible, diffuse region of gas, dust, and dark matter that surrounds it, extending far beyond the visible stars. Halos don't emit light, but they have mass and are crucial to the dynamics of galaxy formation and evolution. The Andromeda galaxy's halo is especially massive, extending over 1.3 million light-years toward the Milky Way and up to 2 million light-years in some directions. Despite being invisible to the naked eye, the gas and dark matter in the halos still have significant gravitational effects on the galaxies themselves. Remarkable research using the Hubble Space Telescope studied the light from quasars positioned behind Andromeda's halo. Quasars are extremely luminous objects powered by supermassive black holes at the centers of distant galaxies. As the light from these quasars passes through Andromeda's halo, it is absorbed by the gas and dust, revealing detailed information about its composition and structure. astronomers discovered that Andromeda's halo is so vast that it overlaps with the Milky Way's halo. This overlap indicates that the two galaxies are already in the early stages of a cosmic collision. Although the stars within the galaxies are still mostly separated, their gas and dark matter halos are beginning to interact, marking the beginning of a gradual and long-term merger. This discovery adds further evidence to the idea that the Milky Way and Andromeda are already engaged in a vast dance that will shape their futures for billions of years. The dramatic effects of the Andromeda-Milky Way merger will unfold over billions of years, beginning with an initial close encounter about 3.75 billion years from now. As the two galaxies pass through one another, their gravitational forces will distort their shapes, triggering massive bursts of star formation as gas clouds collapse under intense pressure. This period of rapid star birth will likely be accompanied by the formation of new stellar clusters and even some stellar remnants like neutron stars or black holes. As the two galaxies continue their slow-motion collision, the night sky will become a breathtaking spectacle. Andromeda, already visible from Earth as a faint smear in the night sky, will gradually grow larger and larger, spanning the sky for hundreds of thousands of years as it draws closer eventually. The two galaxies will separate after their initial encounter, but their mutual gravitational attraction will pull them back together for a final, catastrophic collision about 4.5 billion years from now. This ultimate merger will likely result in the formation of a new, larger elliptical galaxy, often referred to as Milkomeda. At the heart of this new galaxy, the supermassive black holes from the Milky Way and Andromeda will merge, forming an even more powerful black hole. The stars and gas in both galaxies will be reconfigured into an entirely new structure, potentially leading to the creation of new star systems or the ejection of some stars into intergalactic space. As for our solar system, its fate remains uncertain. It could be flung into the outer regions of the new elliptical galaxy or even ejected into the vast emptiness of intergalactic space. However, this dramatic scenario will occur long after humanity's time on Earth has likely passed. Future generations of humans or life forms that evolve from us might witness the dramatic changes in the night sky as the merger unfolds. The potential merger of the Andromeda Galaxy and the Milky Way is one of the most awe-inspiring events in the universe's future. While this cosmic collision will take billions of years to fully unfold, it is already underway, as evidenced by hypervelocity stars and the overlapping halos of the two galaxies. Though the immediate consequences may seem distant, the process itself is a testament to the dynamic and ever-changing nature of the universe. As galaxies collide, merge, and evolve, they shape the cosmos in profound ways, reminding us that the universe is anything but static. It is a living, breathing entity, constantly changing and evolving. The merger of the Milky Way and Andromeda will forever alter the night sky, but it is just one of countless cosmic events that highlight the magnificent and boundless nature of the universe. As the Milky Way and Andromeda continue to move toward each other, their interaction will not only reshape their structures, but also have far-reaching implications for the galaxies within their gravitational influence. Over the course of billions of years, this cosmic dance will alter the position, motion, and nature of stars, gas, and dark matter in ways we are just beginning to understand. Observing this process is crucial to understanding the nature of galactic mergers, which are not quick or direct events. Instead, they are a series of carefully orchestrated cosmic scenarios, each unfolding over vast timescales that allow us to study the galaxies involved even from our vantage point on Earth. One of the fundamental aspects of this cosmic collision will be the transformation of the stars within the two merging galaxies. Throughout the merger process, the galaxies will experience bursts of star formation. These bursts will be fueled by enormous amounts of gas and dust colliding and compressing as the galaxies pass through one another. When gas clouds collide at high speeds, the intense pressure and heat cause the gas to collapse, leading to the birth of new stars. This rapid star formation will create an entirely new generation of stars, some of which will be massive and short-lived, ending their lives as supernovae. These explosive events will disperse heavy elements like iron, calcium, and oxygen throughout the merging galaxies, enriching the interstellar medium and providing the building blocks for future generations of stars, planets, and potentially even life. In addition to the creation of new stars, the merger of the Milky Way and Andromeda will likely lead to the disruption of existing stellar systems. The gravitational forces at play during the collision will pull stars out of their orbits, either ejecting them into intergalactic space or altering their paths within the galaxy. Some stars may even be captured by the supermassive black hole that will form at the center of the new galaxy. This chaotic environment will make it more challenging for planetary systems to remain intact, as gravitational disturbances could displace or destabilize the orbits of any planets in existence at the time. Another fascinating aspect of this galactic merger is the potential for the creation of new stellar remnants. As the galaxies collide, massive stars will burn their fuel more quickly, leading to the formation of neutron stars or black holes. These dense, compact objects will add to the complex gravitational landscape of the new galaxy. Some of these black holes may merge to form even more powerful gravitational sources, potentially emitting gravitational waves that could be detected by future generations of astronomers. The intergalactic space between the Milky Way and Andromeda may also play an intriguing role in the merger. As the two galaxies collide, the space between them will be filled with a turbulent mixture of gas, dust, and dark matter. This region, though largely invisible to the naked eye, will experience an increase in activity as gas clouds are compressed and heated, potentially leading to the formation of new, smaller galaxies or the acceleration of cosmic phenomena such as supernovae. The intense radiation and energetic events occurring in this vast area of space will further fuel the cosmic cycle of birth, death, and rebirth that is fundamental to the universe's ever-changing nature. The fate of the gas and dust in the intergalactic medium is also of great interest to astronomers. As these materials are drawn into the gravitational wells of the merging galaxies, they will contribute to the transformation of the galactic environments. The gases will be funneled into the supermassive black holes at the centers of the galaxies, likely fueling the formation of active galactic nuclei or quasars. These luminous objects, powered by the immense gravitational energy from the black holes, will shine brightly across the universe, providing astronomers with valuable insights into the inner workings of galactic mergers and black hole formation. Furthermore, the collision between the Milky Way and Andromeda will have implications for the larger cosmic structure they are part of. The local group of galaxies, which includes both the Milky Way and Andromeda, is already part of a larger cosmic web of galaxies, clusters, and superclusters. The merger of the Milky Way and Andromeda could influence the dynamics of other nearby galaxies, potentially leading to the reshuffling of galaxy groups or even the creation of new galaxy clusters. As galaxies merge and interact in these cosmic environments, they help shape the structure of the universe on the largest scales, providing key insights into the nature of dark matter, dark energy, and the expansion of the universe. In the long term, the merger will result in a massive elliptical galaxy that is destined to be vastly different from the spiral galaxies we know today. The new galaxy, often referred to as Milkomeda, will be a completely restructured entity with an entirely new arrangement of stars, gas, and dark matter. This new galaxy will likely have a much more spherical shape than the current disk-like structures of the Milky Way and Andromeda. The end of the merger process will mark the culmination of billions of years of cosmic evolution, but it will also raise new questions about the future of the universe. While the merger of the Milky Way and Andromeda is still billions of years away, the process offers a unique glimpse into the dynamic, ever-changing nature of the universe. It highlights how galaxies are not static entities but are constantly evolving through interactions with one another. These cosmic mergers contribute to the ongoing reshaping of the universe, bringing about the birth of new stars, the formation of new galactic structures, and the continuous transformation of the cosmic landscape. The eventual merging of these two galaxies serves as a reminder of the vastness of time and space in the universe, offering a humbling perspective on the lifespan of our own galaxy and Earth itself. For now, we can marvel at the distant future of the Milky Way and Andromeda, knowing that we are living in a fleeting moment of the immense and ever-changing universe.